Welcome. Introduction to Autocorrelation, ACF, and Partial Autocorrelation, PACF. In this lesson, we will explore two important tools for understanding patterns in time series data, autocorrelation, ACF, and partial autocorrelation, PACF. We will use real-world data to see how these tools help us uncover hidden relationships over time. By the end, you will read data, check for autocorrelation, plot ACF and PACF, and build your intuition for time series forecasting. Let us get started. Running the cell now. Think about where you have seen repeating patterns in real life. Weather? Sales? Get ready. Let us understand what autocorrelation means. What is autocorrelation, ACF? Autocorrelation means comparing a time series to itself, but shifted in time. It tells us if past values help predict new values. If last month's sales are similar to this month's, autocorrelation will be high. Running the cell now. Try to spot patterns in your own routines. What does yesterday predict about today? Now let us talk about partial autocorrelation. What is partial autocorrelation, PACF? Partial autocorrelation shows the direct relationship between a time point and a previous value, removing effects of points in between. PACF is especially helpful when figuring out how many past steps matter for predictions. Running the cell now. Think of PACF as asking, does this month directly depend on 2 months ago, or only on the last month? Let us load a real data set of monthly airline passengers. This cell sets up the data we will use. We import warnings and pandas for handling data. The URL points to a CSV with monthly airline passenger counts. We read the data and parse the dates, so months are recognized correctly. We print the shape to see the number of rows and columns. Finally, we look at the first few rows as a preview. Running the cell now. Can you spot any patterns in the first few months? Let us make a line chart to see how passenger numbers change over time. We import matplotlib to create our first chart. Our figure will be wider so it is easier to see trends. We plot the number of passengers for each month. Setting labels helps us know what we are looking at. The y-axis is the number of passengers. We give the chart a clear title. Adding a legend helps with multiple lines if needed. Finally, show pops up the chart. Running the cell now. Where do you see increases or drops in travel? So why do we care about these tools? Why use ACF and PACF plots? ACF and PACF plots help us decide how much history to use if we want to forecast the future. Patterns in these charts reveal how far into the past the data remembers itself. Running the cell now. Get ready to visualize memory in the data. Let us plot the autocorrelation to see repeating patterns. We import a tool from stats models to plot autocorrelation. A wider plot helps us read the details easily. We plot correlations for up to 24 months in the past. Give your chart a simple title. Showing the plot pops it on the screen. Running the cell now. Which lags look highly correlated to the current month? Now let us make a PACF chart for clearer direct relationships. Here, we import another plotting tool for partial autocorrelation. Keeping a consistent plot size helps compare easily. We plot partial autocorrelations for up to 24 months back. A clear title makes the chart easier to understand. Show pops up the PACF visualization. Running the cell now. How does PACF differ from the autocorrelation plot for this data? Let us see some summary stats for the dataset. We calculate averages, maximum, and minimum values for passenger counts. These help us get a sense of scale in the data. We print the mean number of passengers each month. We print the highest value for peak travel. We print the lowest count for less busy months. Running the cell now. Are the high and low months what you expected? Let us see what happens when we make a common mistake. This code tries to access a column called flights that is not in our data. We wrap it in a try block to safely catch any errors. If there is a problem, we catch the exception and print the error message. This helps us debug without crashing our notebook. Running the cell now. Try changing the column name to one that exists. We can make a new column for last month's value to see how shifting works. Here, we add a column showing what the value was the previous month. The shift function moves everything down by one row. Running the cell now. Are increases or decreases more obvious now? Shifting creates missing values at the top. Let us remove them safely. We use dropner to delete any rows with missing values caused by shifting. This keeps our calculations clean. Running the cell now. Did you expect to lose just one row? Now let us measure how strongly this month relates to the previous month. We use core to get the correlation between current and last month's passenger counts. A value close to 1 means a strong pattern. Running the cell now. Does this number match what you saw in the ACF plot? Let us print autocorrelation values up to a year back. We import the ACF function to get numbers for each lag. We look at up to 12 months into the past. Print a header so the meaning of each number is clear. For each month lag, print the autocorrelation value rounded for readability. Running the cell now. Which month lags have the strongest memory? Let us try filtering for summer months to spot seasonal patterns. We create a new column with a numeric month value. Then we keep only rows where the month is June, July, or August. Print the first few summer records to check our filter. Running the cell now. How do summer passenger counts compare to the rest? Now let us plot the filtered summer data on its own. Here we create a line chart just for summer months. Using dots helps see individual points. The x-axis is the date and y-axis is passengers. Set a specific title to show this is just the summer pattern. Show makes the summer pattern visible on screen. Running the cell now. Can you see if summer always beats other months? Let us try a simple mini project. We define a function to predict the next month using the average of the last 12 months. Take the last 12 values of passengers. Calculate the mean and round it down to the nearest whole number. Call the prediction function and store the result. Print our simple forecast for the next month. Running the cell now. How do you think this compares to using only the most recent month? Let us add a 12-month moving average to highlight the trend. We add a new column for the 12-month moving average of passengers. Rolling mean smooths out ups and downs and helps us see trends. Plot both the original data and the moving average for comparison. The moving average trend appears as a red line. Give labels and a title for clarity. We add a legend to distinguish the two lines. Show makes both lines appear together. Running the cell now. Challenge: how would things change with a 6-month average? Let us check if our data is stationary. That means its pattern stays similar over time. We import a statistical test called ADF to check stationarity. Apply it to the passengers column, making sure to drop missing values. Print out the statistic to see the result. Also print the p-value, which tells us if the findings are clear. If the p-value is small, the data does not change greatly over time. Otherwise, there is a trend or seasonality. Running the cell now. Stationary data works best for many forecasting methods. Let us handle any missing data because gaps can break autocorrelation analysis. Count how many values in our passenger data are missing. Print out the count so we know what we face. If there are missing spots, fill them using the last known good value. Forward filling is common for time series to keep order. If there are no missing values, let us know nothing needs fixing. Running the cell now. Did you get any missing values, or is the data complete? Here is a quick tip: look at several lags side by side for deeper insight. Tell pandas to show all columns so we do not miss any. Make a table with columns for the current month and up to 3 months back. Stack the columns together for easy viewing. Rename each column to make reading simpler. Print the first 10 rows to explore. Running the cell now. Can you spot any repeating relationships across months? Try entering your own lag value to see its autocorrelation. Ask the user to type in how many months back to check. If the value is between 1 and 12, use AutoCore to measure the link. Print out the result rounded for readability. If the input is not in range, let the user know what to correct. Running the cell now. Try several values and see how the relationships change. Let us look back on what you have accomplished. Lesson recap. You have loaded time series data, explored autocorrelation and partial autocorrelation, tried basic predictions, and handled challenges along the way. ACF and PACF will help you understand memory in any series that changes over time. Practice with other datasets to build your intuition. Running the cell now. Which step would you like more practice with? You did it! Let us wrap up. Thank you and next steps. Thank you for exploring ACF and PACF in Python. Like, subscribe, and check the video description for more resources and code examples. Happy learning and see you next time. Running the cell now. Share your results or questions in the comments and join our learning community.